Hello, today we're going to talk about deviations from the ideal gas law. Okay, so ideal gases are just that, they're ideal. They don't really exist in the real world, but things that make gases behave the most like ideal gases, so they're more likely to follow the ideal gas law, is higher temperatures and lower pressures. And the reason for that is at higher temperatures they are moving faster and they're less likely to form those intermolecular forces. And at lower pressures, they tend to be more spread out, colliding less frequently. So again, they're less likely to form those attractions. All right, so what happens when you deviate from ideal conditions? So let's take a look at an ideal gas. And then if we take that ideal gas, that same ideal gas, but suddenly we drastically change the volume. Okay. Now the gas only has a much smaller area in which to move. So one of the tenets of the kinetic molecular theory is that the particles of a gas, the volume of those particles is very, very small compared with the volume of the container. When you dramatically decrease the volume there, the volume of the particles themselves actually becomes a factor. It's not negligible anymore. So it doesn't quite work with the ideal gas law anymore because the particles are taking up some of the space in which they can move around in. The other part to this is that if they're much closer together or colliding more frequently, the other factor to consider when they're so close together is that those particles are much more likely to form attractions. If the particles are attracted to each other, then that's going to slow them down and to decrease the effect of collisions, essentially. So that will affect the pressure as well as the temperature, and it just kind of messes up everything. And it becomes a lot more complicated. There is an equation where you can use the change in volume and you can use the change in attractions to account for deviations in ideal conditions, but that is not part of the AP exam. You just need to know that those are the two big things, volume and attractions, that will affect whether or not Pivnert is really accurate or not. So the gas particles that are most ideal are ones that have a very small size, so the smaller molar mass. This decreases the effect of a change in volume. So the smaller the size, the more negligible the volume of the particles. You also want to look at ones that are more nonpolar. The more nonpolar the gas, the weaker the attractions. So if it is forming those intermolecular forces, you would rather they were as weak as possible. So London dispersion forces, and the more nonpolar molecules, the more it only has London dispersion forces.